All right, so this is now the question 1, A, B, and C for chapter 5. It says solve the system equations using substitution or elimination method. State the type of solution. So whether it's one solution, no solution, or infinite solutions. Now, in the whether or not you use elimination or substitution, all of these problems you can use both. But in certain problems, one method works better than the other. So, for example, here when either one of the variables has a coefficient of 1, it substitution might be a better approach. So this is 1x minus y equals 0. So what we could do is we could rewrite this as x equal to y. And then we can use this as a substitution. We sub the x as y in the second equation. So we take the 5x plus 2y equals 14. And we're going to make this substitution here to get 5y plus 2y equals 14. So we get 7y equals 14. Then divide up by 7, which gives you 2. Okay, so we got y equals 2, and then we can go back. Well, x equals y according to our substitution, which just means then x should also equal 2. So we do have one solution here. And it's 2 comma 2. Okay. In the next problem, notice that none of the variables have a coefficient of 1, so elimination may be a better approach here. What we can do is we want to choose a variable that you want to eliminate. So let's say we want to eliminate y. Well, this is 8y in the second equation. So I'm going to try to make the first equation also an 8y, but opposite sign. So I want this to be a -8. Since it's already -2, to make it a -8, I need to multiply by 4. So I'm going to multiply the whole equation by 4. So I'm going to end up with, so the second equation gets readjusted to 12x minus 8y equal 4. Okay, so below it, I'm going to write the second equation, which was -12x plus 8y equals 4. And then I'm going to add them to each other. Well, 12x minus 12x is 0. -8 plus 8 is 0. And then we have 4 plus 4, which is 8. I'll go back. Okay. So we end up with 0 equal to 8. Well, that's a contradiction. Which just means that we have no solution. Okay, wait. I just noticed I wrote down the problem wrong. Actually, the actual problem had a -4 here. So we actually have a -4 here. Okay. So let's just fix that really quick. Okay, if you go back to the actual problem, there should have been a -4 in the second equation. So we end up with 4 minus 4, which is 0. So this gives us 0 equals 0. Okay, well, 0 equals 0, that's a true statement, but it also means that these are independent system. So x depends on y. If we want to write this, it's going to give us infinite solutions. And usually the way we write this is we just take one of the equations, go back to our original. So let's take this equation, which was 3x minus 2y equals 1. And let's try to isolate the x. Well, we'll get 1 plus 2y. And then we can divide out the 3. So this says that X depends on Y. So Y can be any number we want, and X would be 1 plus 2Y over 3. So generally, if you have infinite solutions, this is how you'd want to write out your solution. Okay. Finally, let's look at our third example. So this one also, we don't have a coefficient of 1. So let's multiply this equation by something that would help us eliminate one of the variables. So this time I want to eliminate the x. So since I have 6x here in the first equation, in the second equation, I want negative 6x. So I'm going to multiply by negative 2. So my second equation becomes negative 6x minus 8y equals negative 30. I'm going to put this equation below it. I get 6x plus 8y equals 1. I d0 out, d0 out, and we're left with equals negative 29. Well, that's 0 equals negative 29. This is the contradiction, so this would be no solution. Okay, and then so that's it for the last one.